we're the organizers of this event. We're also the publishers of Tech Briefs magazine, which we have copies, if you haven't seen it or picked it up, copies of our latest issue that has profiles of all of our finalists that are here today. So please do take a look at that. But you'll be hearing from each of them about their great ideas coming up. So this is the 23rd annual event. That means I started with it when I was 15. So it was really incredible. But it's been my privilege to be part of this from the start, and it's one of the most exciting things we do, certainly, and I think it serves a real great need and public good. Because this contest isn't just about big ideas. It's about big ideas that can make a big difference in the world, that can improve daily life, that can save lives, that can help our economy. Not sure it's going to help your flight from Newark Airport when you leave here, but we can only do so much. And it was a big year for us. So even in our 23rd year, this event keeps growing. So we had over 600 and I'm going to not be exact, let's say 630 plus. So over 630 entries this year. But the most exciting part of that is it was from 67 countries. So this is truly an international event. It was a record setter for us in terms of the number of countries participating. And that's going to be represented. You'll get a real international flavor as we go through today's program. So if you do the math on that, your chances of being here as a finalist were about 1%. And you had to go through 3 rounds of judging. I was explaining somewhat earlier. We're fortunate to have a great group of 13 judges here with us today, but there's over 60 judges through the entire process who participate, and some in multiple rounds, but who participate through it because we start with that large group, we winnow that down to a top 100, and then we get to you. And when I say you're all winners, I literally mean that in a number of ways. I'll tell you a story related to that. So back in 2018, I went to the big Consumer Electronics Show. And if you've ever been there, you know it's these enormous exhibits of everything in automotive and aerospace, et cetera. And tucked in the back of one of the halls, there's this tiny exhibit booth from a company called Meld Manufacturing. And Meld, I walked up and said, "What do you guys do here? This is interesting." Said they were a startup just getting going that made large-scale 3D printers. But what was interesting about what they did is they were able to 3D print metals for the aerospace industry, in particular certain grades of aluminum that no other 3D printers could do. And so now you could produce tank parts and so forth on a scale using their 3D printers. And I said, you know what? We have a contest for you. And so the founder, who I met that day, decided to enter the contest. That year, they won the manufacturing category in our first place in manufacturing category. Fast forward to this year, I was attending another conference. It was from the Society of Manufacturing Engineers that was all about 3D printing and additive manufacturing. I'm walking the show floor. Lo and behold, they're in a giant booth, 10 times the size of what was at the Consumer Electronics Show, is Meld. And there's the founder. And I said, well, how you doing? They went from 2 employees at the time to dozens, multi-million-dollar profitable business, a whole new set of 3D printers that advance beyond the first stage, all kinds of investors participating. And the comment was, we couldn't have done it without you. The publicity and the exposure and the credibility and the thrust we got from being part of the Create the Future contest was integral to our success. So the message I want to share there is she wasn't the grand prize winner. So yes, it's wonderful to walk away with the $25,000 check, no question. But every one of you are winners because you got this far and you can take this. And hopefully, what we want to see happen is I'm walking around that show next year or whatever show it is, and there you are, and you're a success, and you're out there. That's what we're all about. We're all about helping great ideas find their way to practical use where it makes a difference in the world. And so I congratulate all of you for getting this far, because it sure isn't easy. So with that, I would like to shut up and turn it over to the person who will take us the rest of the way in the very capable hands of Chitra Sethi, who is the editorial director at SAE Media Group. Chitra?
It's hard to follow, Joe, but I'll try. Well, welcome to the final live judging round of the Create the Future Design Contest. Well, we do many shows, but this is my favorite. We are so excited to have you here as we celebrate the power of bold ideas, spirit of innovation, and the future of engineering. Today, we'll hear from some of the brightest minds who have dared to imagine what's next and turn those visions into real impactful designs. It's a showcase of creativity and the kind of thinking that designs the future. So get ready to be inspired, amazed, and energized as you hear from all our finalists today. Over the next couple of hours, 7 finalists will be pitching their ideas to a panel of our esteemed judges right here in the front for the coveted grand prize of $25,000. But before we begin the pitching round, I want to thank our esteemed sponsors, without whom this event won't be possible. So thank you to our platinum sponsor, Mouser Electronics, an authorized semiconductor and electronic component distributor focused on new product introductions from its leading manufacturer partners, serving the global electronic design, engineer, and buyer community. The global distributor's website, mouser.com, is available in multiple languages and features more than 6.8 million products from over 1,200 manufacturer brands. Mouser Electronics has grown tremendously in the last few years to meet growing customer demand and houses the largest inventory of the newest electronics components in the world. I would like to welcome Heidi Elliott, Marketing Communications Director for Mouser Electronics, who's here with us today to say a few words.
So first of all, thank you, Chitra Sethi, for that fabulous Mouser commercial. Everyone knows what we do. I don't need to say anything about that. And really congratulations to all of the finalists. Your presentations, which we'll see in a minute, your innovations are amazing. Throughout my career, people have always said, make sure you are, if you want to succeed, make sure you are not the smartest person in the room. And I will tell you that today I do not have to worry about that at all. So I will not stand between you and finding out who wins. You guys have a very hard decision. Good luck to all of you. I love all of your ideas. So looking forward to the rest of the program. And thank you.
Thanks, Heidi. And now I want to thank ComSol for being the platinum sponsor, not just this year, but for 2 decades, since the early years of this design contest. ComSol, if you don't know already, is a global provider of modeling and simulation software used by engineers and scientists in all fields of engineering, manufacturing, and scientific research to simulate designs, devices, and processes. Its platform product, ComSol Multiphysics, includes functionality for creating physics-based models and simulation applications, as well as workspace for modeling and simulation management. The software makes it possible to model single physics and fully coupled multiphysics. And with that, I would like to invite Bernd Nilsson, President ComSol, to say a few words.
hello everyone, and thank you very much, Chitra, for the nice introduction, and really impressed by your knowledge about our software. So I don't have to talk too much about that either, I guess. But yes, it's our 20th anniversary sponsoring the Create the Future Design Contest. So we're super excited about that, and it's been a great ride with you guys, and we're looking for more. We want more, so keep doing what you're doing. It's very impressive. And I want to thank SAE Media Group, Tech Briefs for organizing. I think it's getting bigger and better every year, so very impressive. And it's great to be here with you all today for this exciting finish of the contest. And I want to big congrats to all the category winners here today, and looking very much forward to seeing your presentations. And the judges, you've done a tremendous job reviewing all those 600 entries, and you're still here, so great job. And talking about simulation, I think, it's just growing and growing and growing. And just when I came here, I had a great conversation with one of the winners here today that, they're using COMSOL and simulation, and that's great. That's what we want to hear. So I think this contest is really a great example on how design engineers, scientists use simulation software like COMSOL to bring their ideas to life. So keep doing it, and we're very much looking forward to your presentations. Best of luck to you all, and thank you very much. Enjoy the rest of the event here. Thank you. I'm not done.
Where's Oscar? Let's get Oscar.
Oscar.
Let's get Oscar. So Oscar Littmark is Marketing Director of COMSOL. Welcome, Oscar. And we have for you mentioned 20 years, a special, we don't normally it's the sponsors giving the awards, but today it's a special occasion getting. So this reads that in grateful recognition of 20 years of vision and commitment presented to COMSOL, COMSOL's unwavering support of the Create the Future Design Contest has inspired engineers worldwide to turn ideas into reality and empowered innovators to shape a brighter tomorrow for us all. So congratulations.
Thank you.
On 20 years.
Thank you very much. Thank you very much.
Congratulations again.
Right, thanks, Brendan, Joe, and Oscar, and please join me in a round of applause for all our sponsors one more time. And now, let me explain the pitching round and some ground rules for the competition before we get started. The 2025 contest rewards innovation in 7 categories: aerospace and defense, automotive and transportation, electronics, energy, power and propulsion, manufacturing and materials, medical, and robotics and automation. There were 2 prior rounds of judging to determine the 7 finalists, 1 for each category. The 7 finalists will be pitching their ideas to our judges. Their presentation will cover what inspired them to develop the invention, how it works, what makes it innovative, where it will be or is being applied, and its potential impact to the markets served, as well as how the technology, as Joe mentioned earlier, will help realize the future and serve the society. Each finalist will have maximum 10 minutes to pitch, followed by a 5-minute Q&A with the judges. There is a maximum of 20 points, half on innovation and novelty of their idea, half on the strength of its applications and potential to help realize a better tomorrow. Based on the judges' combined scores, one $25,000 grand prize winner will be named, along with the first place winners in each category. If your entry is not chosen for the grand prize, you will win your category. I would request that you must keep to the time limit of 10 minutes, as we have a tight time here. We will have a last 1-minute warning sign go up. My colleague here at the back, Chris, he will have that 1 minute warning sign. So I hope you all have timed your presentations already, but that will be your warning to kind of wrap it up. And if that goes up, it means you're close to the 10-minute time limit, or it'll be cut off at 10 minutes. I also want to remind the judges that there will be no more than 5 minutes for the Q&A for questions following each presentation. If we don't get to your question due to the time constraint, please bear with us. And speaking of the judges, now I would like to thank each of them for participating, for being here, and I want to introduce them. So if you can either raise your hand or just stand up, wave to the audience at the back when your name is called out. Malat Arar, Staff Engineer, General Electric Company. Eric Barnes, Senior Technical Fellow, Northrop Grumman. Jeff Crompton, Chief Technology Officer, SBCI. Tyrannus Taprick, CEO, Neuropair, also our 2023 Grand Prize winner. Brian Dengel, General Manager, KHK USA. Inma Galvez, Supply Chain Quality Manager, ITP Aero. Joseph Lipman, Director of Device Development, Henkel Corporation, is retired. Rohit Ramnath, Senior Product Engineer, Masterbond. Scott Richel, Application Engineer Director, Mac Molding. Susan Stanton, Partner, Redwood Invitation Partners, Principal, SPCI. Adnan Turki, Senior Professor, Engineering, Devry University. And Paul Cotti, Founder and CEO, MRA Mates, LLC. Well, he has the best seat right there, by the bar. Well, thank you to our panel of judges comprising leaders from engineering and technology fields with decades of experience and expertise. We appreciate your time and effort here judging the round, and a round of applause for all our judges. So let's get started with the pitches. Well, we picked literally, the order out of a hat, as Joe says. So, yeah. So here we go. We're going to start with the automotive category. I would like to invite the first presenter as finalists for our automotive and transportation category. Please welcome Mansoor Masoudi and Nikolai Polaikov, presenting Making Diesel Engines Nearly Emission-Free. Forward and back.
Thank you very much. Thank you very much for the opportunity to be here. We are grateful, and we want to thank the SAE team, especially for bearing with many of our questions. Why are we here? Before I go there, this is Nick, my colleague. I'm Mansoor, and along with a couple of our other colleagues who are not here, we are the co-inventors of this technology. Why are we here? We are trying to free the world from a global problem, and the global problem is the use of diesel engine, which is all over the place. So we have a problem of global proportion, and we probably have a solution for that, which we want to share with you. Let's talk about nitrogen oxide, the most difficult emission species coming out of diesel engines. I've been in this space for 25 years. You have to take it with a grain of salt. It's the most difficult, heavily regulated emission species coming out of diesel engines, most difficult in terms of getting rid of it. The rest of them are not that difficult. This is very cumbersome. But what are nitrogen oxides, or NOx? They are essentially NO and NO2, which people call NOx or just NOx for simplicity. And they're naturally produced in engine. How? As air, which is nitrogen and oxygen, like we have in this room, completely benign, are pulled into the engine. In the heat of the engine, oxygen and nitrogen react with each other. They don't in the room, but they do in a heated environment, like an engine. And they make nitrogen oxide, or NO and NO2, or simply NOx. But what's wrong with NOx? Well, there are a lot of things wrong with NOx. Remember, I said this is the most difficult species to reduce in diesel emissions. First of all, they cause acid rain. Ground level ozone. They're bad for our hearts, and not just humans, any biological system. This could be cows in a herd grazing next to tractors or construction equipment. They're bad for our lungs, again, biological species. They are bad for our cognition and neurological systems. And in long-term exposure, they even cause swelling tissues and muscles and so on. Even Veteran Administration, VA, has a category of highly exposed to diesel emissions, and they qualify for VA benefits in the Army and so on. So how big is the problem? So that's the problem, and that's how it comes about. How big is the problem is that we got 110 million diesel engines in the world operating on a daily basis, and about 14 to 15 million more are added each year to this population. So it's a massive population of diesel engines operating daily around the world in diverse sectors. Light duty, which is basically passenger car sectors, is still in Europe and countries like India, 25% of passenger cars, about 20-25% are still running diesel because of the economics of diesel fuel. Heavy engines, medium trucks, these are the ones that go around town. Heavy trucks, these are the ones that you see on freeway. On-road vehicles, those are off-road, that's farming equipment, tractors and combines and harvesters, construction equipments, power industry. 95% of marine vessel engines are diesel. Mining equipments are almost 100% diesel. Industrial power, locomotives, data centers. Every data center, every single one of them uses hundreds, with an S, hundreds of diesel engines for emergency backup. So actually that market is actually growing. So we have a problem of global proportion. So what is NOx Zero technology, which is our invention? It substantially lowers NOx emission from vehicles by an additional 20 to 100-fold. Additional here means above and beyond factory installed catalyst and emission control systems in vehicles. There are a lot of regulations. To their credit, EPA and especially California has an amazing regulation in that area, and OEMs have to meet those regulations and certify to their regulations. That's why this field is heavily regulated. But those factory installed systems don't always work, and that's where our invention really fills a major gap. We increase the efficiency of those systems by an additional 20 to 100-fold, sometimes even more. The way it works is that our device maximizes catalytic reactions in the downstream catalyst by providing an abundance of ammonia and heat. And those are the two key things that catalyst needs to reach its maximum performance. And our device or technology does exactly that. I forgot to bring the mixer. If you don't mind, Nick, grabbing them from the samples from my backpack, please. We got a couple of replicas here. It's a electrically heated unit that sits downstream of one of the injectors in the diesel exhaust. Everything else is factory installed. We just have an add-on component, which is the NOx Zero unit. It's energized by the vehicle battery. It's controlled by a microcontroller. So microcontroller receives several signals from the system, and based on that, it decides to energize the NOx Zero unit, how much to energize, when to energize, and sometimes even not to energize it. So in terms of its operation, is very optimized. So through this process, by adding our component to the system, we can turn NOx coming out of engine, which is highly toxic, to a completely benign nitrogen species, which exists in the air and is completely harmless. What are some of the features of this invention or device? It's extremely low cost. We can make these with less than $10 a piece, and we have done it. They are very small and easy to fit in the emission control system. They are very durable. We have put them into 1,500 degree Fahrenheit engine testing, actual engine, for up to more than 100 hours, and they still come out and work just fine. The other benefits of it are really economics of it. So it's not just emission reduction. If you're a truck owner, if you're a fleet owner, it also reduces your downtime, so there are economic benefits to it. So people get more intensive to see this on their engines. It lowers the warranty cost for a major OEM. I used to work for one of the big OEMs in that area, and we had several $1 million of warranty, and that's pretty much across the industry of just specifically for NOx reduction catalyst. It saves fuels based on our latest analysis. It saves it could save 5 to 7% of fuel, and that's an additional, which for a fleet could be substantial cost saving. And finally, it is good for OEM and for retrofit. We are being approached by several parties on why don't we use this for retrofit, not just in series production at the OEM level, but also by retrofit people. So, for retrofit applications. Here are some examples of how good it works. LLC. A lot of these details really depends on what the vehicle is doing. Are you idling in the parking lot? Are you going stop and go from one light to another in the city? Are you on the freeway burning a lot of fuel? There are a lot of variations of this. We call that drive cycle. So a lot of the details depends on what drive cycle are you in. On the left-hand side, we have the so-called LLC, which is low load cycle. That's one of the most difficult drive cycles for NOx emission reduction. You could see that we reduce the impact of the factory installed emission reduction system, which we call a baseline, by a 23-fold. In the other cycle, we can increase the impact of the factory installed emission reduction system by more than 2 orders of magnitudes. We bring it to virtual zero emission. We have done like 20 of these cycles. We don't have time to go through them. These have been published in about more than half a dozen publications in peer-reviewed journals, by the way. So the impact is real, and there is a lot of evidence that this could be a reality. This is really a solution for a global problem. Remember the 110 million diesel engines operating and 14 million more adding every year? That's not a small scale. And how about the alternatives? Electric trucks, fuel cells, hybrids, etc. Well, those make sense, but the economics are not there, not even close. For example, you can grab a combustion, a brand new truck, medium duty or heavy duty, anywhere between $80,000 to $120,000, brand new. A fuel cell truck costs at least $500,000. So the ROI, return on investment, is just not there. Hybrids, more than $250,000. The economics are not there. We will eventually get there, as we have learned from solar industry and wind industry and so on. We'll eventually get there, but we need another 20 or 30 years R&D and cost reduction till we get to massive scales and those costs come down. Well, we can't wait till 2050 or 2070. We need something in the interim. This could be one of those viable solutions in the interim. So we have a solution for a global problem, and we are hoping we can make a difference. This technology has won several awards so far. It was a finalist in the R&D 100 award competition. Just last year, it won a significant prize from the SAE called a John Johnson Award. And the committee on that were very seasoned committee, some of the best in the mobility industry. We were really honored to get that. It won the German Innovation Award, and also, obviously, we are honored to be here in this competition. And just a couple of months ago, it was featured by European Association of Automotive Suppliers, massive organization of 30,000 members, company members, as one of their featured innovation in 2025. So there is enough credible evidence that we are up to making a change in the industry. I want to thank you very much, and if you have any questions, I'll be happy to answer.
We'll take questions from the judges. There are mics in the front. So, anybody? All right.
Sorry for asking. I'd like to understand what is the difference with other catalyst solutions, which is the novelty of your solution.
I'm sorry, could you?
What is new, what is different with your system?
Yes. So thank you. So the catalyst is already in the system. What is new is the component we add to the system that makes catalyst achieve its maximum performance. So this component is already in the system. Our addition is this unit here, which is energized by the vehicle battery.
Next question.
There have been many studies showing that what we call in-use emission certification obviously look great, but in in-use compliance, they are well below the certified limit. They emit more than 10 times the limit they are supposed to be emitting. So the catalyst is there, but it doesn't work as efficiently. We are closing that gap too. Yeah, go ahead, please.
So in the slides that you had on the website, there's like a top of it where it says there's a deposit forming from the regular fluid. Is that part of it? I think you say that you vaporize it. And then the temperatures in the regular system, how do they compare with the airflow when you heat it up?
Great question. So yes, I didn't talk about deposit. These systems have injected urea in them. Every new diesel truck in the US since 2010, in Europe since 2004, has an additional tank that injects urea into the system. And the urea, when the temperature is not ideal, actually not only doesn't make ammonia, which the catalyst needs, actually turns into solid deposits. And that's a problem in the industry. It damages things. Isuzu has been very interested in that. They have done 2 rounds of studies on our component, and we have published papers together. So briefly, when I talked about the economics of it, lowers warranty costs, that's really what I was talking about. Takes the deposit issue out of the way, saves an OEM millions of dollars a year. That's one of the economics features of it.
So in one of the slides, it said like there's 2,200 times more ammonia available, but that's really not the injected amount, but it's just like made more accessible, and you're not wasting it on the deposits, or?
So the urea, injected urea, which is a standard and factory installed, is meant in the heat of the exhaust to produce ammonia. But that's if you have the right amount of heat in the exhaust. If you don't, then not only urea does not become ammonia, so the catalyst is sitting there doing really nothing, and also the injected urea becomes deposit, which causes warranty cost. With our invention, we make sure that the injected urea does become ammonia. Catalyst can do its job, as well as getting rid of the warranty cost.
What the temperature range, how different is it?
So that's where the microcontroller comes in. When the exhaust temperature is low, it tells the NOx Zero unit to kick in, sometimes with a little bit of energy from battery, sometimes with more. Typically, the urea injection starts around 130 degrees centigrade or Celsius in the exhaust temperature. People don't inject below that specifically for the purpose of deposit. That's OEM's decision. With our technology, as soon as they inject, the NOx Zero unit comes on and then make sure it does become ammonia. And I can tell you, NOx reduction, 130 degree exhaust temperature, which is essentially city driving, is very, very, very difficult. But we have made it happen.
So
Yeah.
one last question.
Sure.
The urea is something that is currently being done commercially, or
That
this
is-
is a unit that you have to add in addition?
The urea injector is already factory installed.
That they do that with vehicles today?
Yes,
Oh.
since 2010 in the US, since 2004 in Europe.
So you're doing this reaction with nitrogen, urea.
Correct.
In addition to eliminating the NO2 and NO, you're also creating a lot more CO2, correct?
We are reducing CO2 because our technology allows burning 5 to 7% less fuel. And fuel and CO2 are the opposite sides of the same coin. You burn less fuel, you have less CO2.
But you're going to produce CO2 in this chemical reaction as you.
No, there is no CO2
No
coming out
CO2
of
in this
there is no CO2 coming out of urea transformation to ammonia.
Okay. Okay.
Yep.
Thank you.
Yep. Thank you.
Thank you, Mansoor and Nikolai. That was a great presentation. Next, we have the medical category, courtesy of our gold sponsor, Zeus. Zeus is a global leader in advanced polymer solutions, specializing in precision extrusion, catheter design, manufacturing, and assembly, serving medical and industrial markets worldwide. Zeus collaborates with customers to advance next-generation devices and technologies. Through materials, innovation, and engineering excellence, Zeus enables higher performance, reliability, and breakthroughs that improve lives. We have with us from Zeus today, John Campanelli, Director of Research. So if you could just stand up, we want to say hello and shout out to Sulser. Thank you. And presenting the medical category finalist, blood viscosity, the next vital sign, a wearable breakthrough in trauma, sepsis, and vascular health, is Nilesh Salvi. Oh, you wanted to lower? Can see if this helps.
Hi, everyone. Thank you. Viscosity is a tendency of fluids to resist flow. And consider a soda vending machine deploying a milkshake. The thicker fluid, milkshake, will exert excess pressure on the walls, leading to pipes getting worn quickly. The pump will have to work harder, and the tight spaces will always get blockages, so nightmare for maintenance. The blood circulation system is no different. What's going to happen is the tight spaces in terms of blood flow will be capillaries, where the entry site were in vital areas, where if the thick blood cannot get through, it's going to lead to organ failures, strokes, bad news. The pump that's working hard, that's your heart. It's going to grow stiffer over time, precursor to heart diseases. And the pressing against the wall, which is the high blood pressure, which chronically leads to hypertension. Viscosity in reality is driving all this bad news around, but we're not looking for it. We're not measuring it, not because it's not important, because we can't measure it, not the way it matters. So today I'm here to tell you that we have solved that problem. We are basically working with current day methods that require drawing blood, taking it to a lab, subjecting it to a mechanical deformation, which involves instruments that are very expensive. And through this transformation, the sample has been substantially altered. But more importantly, at the same time, the circulatory system, it's dynamic, it's gone, it's changing inside the patient. And so the two things, the sample and the circulatory system, there's very little resemblance between the two. And so the one piece of data that we got through all this ordeal has very little clinical value now. And that's the problem with current systems. With waves, we are basically able to put the sensor on the patient. It's continuously generating real-time viscosity measurements, and it's implemented with off-the-shelf components, no moving parts, very inexpensive to implement, but most importantly, no drawing of blood. And the device basically sends an ultrasound wave, a continuous wave, through the medium, and the resulting signal is analyzed with fundamental engineering principles. No sophisticated algorithms there, no AI involved, no hyper-specialized hyper-manufactured components. So simple hardware, simple software put together. And we have tested it in internal combustion engines at first. We were on our way by basically getting the lowest hanging fruit with this technology. We wanted to measure oil viscosity. Oil is the simplest medium to work with as a Newtonian's liquid. And that design sits in the oil pan of a diesel engine and in real time generates oil viscosity data. Basically, we were trying to guide preventive maintenance. But we have translated that device over the last 6 years into this wearable device that could be deployed safely, which uses ultrasound, in humans. But it all started with a patent that was granted to University of Missouri in 2020, which was about measuring viscosity in situ without non-invasively using ultrasound, which was a result of my PhD research. And we co-founded it, me and my advisor, we co-founded a company that was basically de-risking that technology for an industrial problem, basically monitoring viscosity in internal combustion engines. But the problem was we had to dip the sensor in the oil. The oil gets dirty, leads the sensor to get dirty sensor being bad for data. And so our goal was to separate the sensor from the oil and still be able to measure the properties that we are interested in. So we basically had to extend our theoretical framework to work across multiple layers. And while we were working that, it was a problem that we referred to as like a sensor fouling at the time, which was very much interested, industry was very much interested in. We were focused on that, two of us engineers. But our clinical friend decided that, he made us realize that how it is relevant to a clinical problem that he's struggling with. So we collaborated and we tested a prototype in rats to monitor the changes in their hemodynamic state when we inject it with known fluids. And that was the first time we saw viscosity in action in an organism when it is subject to fluid shifts. And that led to another discovery because of the way experiments were designed. So like we're transferring a known fluid with known composition and known volume and causing measurable changes, which allowed us to see the total volume, the total load under circulation. So we basically have a multi-feature prototype that measures total volume, which was of interest in bleeding patients, when you're losing volume. So, in critical care. So we have a prototype that can be deployed safely in humans with this multiple features. Where do we go from here? The applications are vast, but we want to focus on things that are areas which are recognizing viscosity as a critical factor right currently. So kidney, blood, and critical care. That's where we are currently focused on, where transfusion care is the primary mode of treating patients. And some areas where drug development can be guided, or hypertension, where the connection is established through clinical care, but will still require substantial research to justify use of such technology in that area. So those will be promising yet distant goals for us. So right now we're focusing on renal markets, critical, and hematology. Those are already making shifts towards use of AI-driven, non-invasive sensor systems, but they lack the richness of data, which is missing. So where we can make a lot of contribution, this can make a lot of, this could be a game changer with the kind of granularity, with the kind of, the richness of data basically for blood rheology. And more importantly, the technology we have is, there's no serious technical bottleneck. We have a patent in place, and most importantly, there's no other device like this. So if we address this market at this point, we are very likely to make a difference, especially in the addressable market area, where the transfusion care is important. But it's it's guarded by the FDA approval. So instead of, we might bleed out until then. So instead of directly confronting it head on, we want to go for a less guarded, more practical approaches. We want to bring this to research labs to enable more clinical research with the real-time measurement capability of viscosity. The team is engineers, clinicians put together. Dr. Tan, he hired me as a student years ago, 2011. We've been working together. We published. We went in business together, and now we are very close to. And we have surrounded ourselves with clinical friends in key areas who are helping us recognize the problem. Dr. Fay helped me recognize how the clinical significance of the technology, and Dr. Fergus is when my hands were knee like elbow deep in engine oil. And Dr. Fergus is supervising our hematology feasibility studies. Dr. Lee is our animal research guy. And we are all guided with experts in MIC to develop business model. So we are basically leveraging our startup momentum, the customer discovery that we've done, and the SBIR success to basically reach the research markets, and working with an OEM partner to place a consumer product in wellness area. All the data, the early revenues will feed into will support the FDA approval process, while we are also able, which will be crucial towards integration to clinical and military. And more importantly, it will allow us like a software as a service kind of a product, which is very relevant to pharma labs. And more importantly, beyond business, we are here at an opportunity to make a paradigm shift. We are interested in, don't get me wrong, the impact is pretty clear from preliminary data that it will have on the care. But more importantly, the patterns with the complex diseases like hypertension, where there's no apparent connection made in viscosity, and so the drug development is going in a very different direction. The impact it will have in that area will be substantial. It will be breaking new medical grounds. And that's where we want to make a difference. And that's why we are committed to bringing this to clinicians, researchers, and medics who will help us bring this whole picture of hemodynamics with viscosity at its core. Yeah. Thank you.
So you have a non-invasive test method here, and you've tried it on a rat or a mouse or whatever it was. Well, if it's non-invasive, why not just put it on your arm and try it on a human being?
Yeah, we can, but the shifts in viscosity are invasive. So we have to subject the person to an infusion. And to do that, we have to run a pre-clinical study that has to have a IRB approval. So we aren't there yet. The pending support with NIH is going to enable that.
This is great. As an aerodynamic guy in aerospace, why did you not including density?
Actually, the patent is covering density and viscosity. Well, we're interested in viscosity right now. But yeah, it's the product of density and viscosity would lead to a parameter that allows us to focus on it. But the changes in density, they can get a little bit more complex with this multi-phase fluid.
Yes.
So we're going to treat it as a compound factor rather than treating it separately.
Okay, ma'am, thank you.
A question at the back.
Thank you. It's great that you identified the markets. Thank you very much for doing that. It wasn't in your original write-up. The fact that you've identified the regulatory pathway is great. Have you looked at the reimbursement pathway at all? Because that's going to be instrumental in whether or not organizations will use it.
I'll investigate that.
Okay.
So, blood by itself is Newtonian?
No, it's
all right, so non-Newtonian. Mm-hmm. So your measurement, you inject another fluid with it, and there's an expected viscosity shift that you look for?
That's right.
And then depending on what that shift is, it's an indication of a problem or not?
Well, analyzing it in a context of what happened to the patient. If it's a patient that's bleeding, the overall volume drop itself is not going to reflect by itself in viscosity alone. But if it is happening in context of a transfusion, then we know what phase of fluid we are injecting it with. So we expect the viscosity to drop. So it has to be done in a context of what the procedure is, the treatment is.
Any other questions? Sure. Yeah, fine.
Do you have a picture of a prototype or how the device actually looks like on a rat? Or
yeah, more importantly, it's more of on a rat.
I mean, you used it on rats, right?
Yeah, I don't have a picture with me, but yes, it's more like off-the-shelf components, basically held together by a 3D printed harness, and would be fun to watch. I didn't want to put a rat on the wall.
All right. Thank you, Nilesh. Next up is the robotics and automation category, sponsored by Maxon. Maxon develops and builds high-precision electric drive systems that are among the best in the world, combining brushed and brushless DC motors, gearheads, sensors, spindle drives, and control electronics into complete mechatronic drive systems. For over 60 years, businesses from a wide range of industries, including medical technology, robotics, industrial automation, mobility, and aerospace, have placed their trust in reliable drive systems by Maxon. I would like to invite Tyler West to present his team's idea in the robotics and automation category, the Woodpecker.
Okay, if I take this off here. All right, thank you, everyone. Thank you for the opportunity. It's great to be here today. My name's Tyler, and today I'm going to introduce you to Woodpecker. So Woodpecker is a utility pole climbing robot that my Capstone teammates and I built to assist in the job of a line worker in building and maintaining our electrical grid. We've worked on this idea for about a year now, from idea all the way to a fully functioning prototype. And today I'm going to walk you through what inspired us to do it, how it works, and where we see this going in the future. So let's start with the inspiration. This actually came from our University of Waterloo final and undergrad engineering project. And we're mechatronics engineers is what we're trained in. So we were looking to see how we can use robotics to change the world. We looked at the world around us, and we looked at all kinds of different problems and applications and tried to balance the amount of time that we had, our skill set, and where our interests lied. And what we decided on was the job of a line worker. These are the people who climb utility poles, they go up in bucket trucks, they maintain the grid, and they do all kinds of work in a very dangerous field. We wanted to help them. So I actually talked to one of my friends who is a line worker, and we learned all about his job. They do lots of different things. They install hardware, they manage the vegetations on the poles, they inspect the poles, switch the power on, repair storm damage, and they drill those holes when they're installing new hardware. So we needed to find something that fit in about 8 months, was about how much time we had to build this. And we wanted to find a simple place to start. So what we decided was we were going to build a robot that can climb and drill utility poles at any height and any angle. And that's what we did. So here's how it works. At a high level, there's a hexagonal frame and 3 wheels that clasp onto the pole from each different angle, held on by a passive spring suspension system on each wheel. 1/3 of the device frame can be swung open with the hinges and latch that are on there in order to get it on the pole and off the pole when you're done using it. And then mounted on top of the frame is a 180-degree track to allow the drill to go to any angle and drill through holes. And then it's driven into the pole using a linear actuator and out of the pole with the same method. This is what the deployment and setup looks like when we were testing. First, you remove it from the trailer, then you open the hinge and swing the latch open, put it around the pole, adjust the wheels, and then refasten the latch before we move to the next step. The next step is a system we had to design to deal with the compression of the springs. So we actually designed the system so that a bolt holds the compression of the springs, and you pre-compress them before putting it around the pole. That way, when you actually put the latch in place and have the device in its correct position, you can then loosen that bolt, and the compression moves from the bolt onto the pole, which generates enough friction force to allow you to be able to climb up the pole. The climbing up the pole looks something like this. There's an electric motor on each of the individual wheels on the device. And then there's a control system that makes sure that the device stays balanced as it's going up to ensure that it doesn't fall by becoming off balance and then slipping down the pole. On top, there's a tool mounting track. It's 180 degrees, like I said, and it uses a stepper motor to drive it around. And you can just kind of see how it works there. And then here's a video of how the drill works when we were testing it. Essentially, it's just a linear actuator driving it in and out. And then there's another stepper motor that controls the trigger on the drill for how fast the bit is moving. Some of the key innovations associated with the design include one, it's adjustable to different pole sizes. So for those of you who don't know, wooden poles come in many shapes and sizes and classifications for different purposes. So we needed to design around that. So what we ended up doing was we actually had a system where we used a little latch there, I guess, with individual holes for the different diameters of poles that you're operating on. And how it works is you kind of grab it with two hands and you can pull the wheel to the correct diameter of the pole that you're operating on. And then you do that before you loosen that bolt and apply the compression onto the pole. The other one was the 180-degree track so that we can drill the holes at any angle. We're on a bit of a budget, so what we did was we CNC'd out a piece of plywood into this shape that we needed here. And we actually 3D printed each individual piece around this entire thing. And what they are is it's inspired from like a planetary gear, so that the stepper motor drives the gear on the inside, and then there's a gear on the outer track so it can glide around. And that's about the resolution that you can have to find any angle around the pole. And the final innovation is that it's a completely self-contained electrical system powered by an e-bike battery that we managed to find. And this way you don't need to have an additional power source like a generator on the ground or a tether running from it. Some future applications we see include using it as it was originally designed to drill holes accurately during new pole installations to mount hardware on after the fact. The next one is we could swap out the drill attachment for a different attachment such as a concrete saw to help with the job of removing concrete poles in urban areas. Here, this is a really dirty job right now where a lineman has to get up in a bucket truck and they get sparks and dust and different things in their face while they're doing it. So our tool would swap them out. It would go up, cut off a chunk, a crane removes it, come down, cut off another chunk, a crane removes it until the entire pole is removed. And then the final one we want to use it for is replacing it with a wrapping attachment. So as you may know, there's a pretty big wildfire problem coming up and only increasing with climate change. So one solution that a lot of utility companies are using now is wrapping these poles in a fireproof intumescent mesh wrap. Right now, people have to climb up the poles or go up in a bucket truck in order to do this. So we would swap out our attachment for a wrapping attachment instead. It will go up and wrap instead of a person. And finally, our market impact. We really believe that using this technology, lineman crews can become more efficient and have faster operations. There's also improved lineman safety in terms of keeping them on the ground more often at less risk of heights and less risk of being electrocuted while up there. And overall, we really hope that this is a next generation platform on which utility robotics can be built to continue to make the job of a lineman safer. Thank you.
Other questions? Anyone? The back, please.
Yes. It's great that you did all of this innovation and you've solved a lot of problems from a technical side. Have you gotten any customer feedback at all? And you said you have spoken with one lineman. What are they willing to pay for it? And what's your cost to produce it?
Yeah.
And are they willing to use it?
So it's very early in terms of, this is a V1 of the prototype. We worked with our local utility, Nova Power, when we were testing. That's where all that testing footage comes from. I don't have an answer on the willingness to pay aspect of it right now. That thing's about 200 pounds right now, so we would need to do a full V2 spin to actually put it in front of people to test if they would be willing to use it if it was a lighter form factor that like only one or two people could be able to carry it onto the pole. And that would be the next stage of development that we would need to do to help answer that question.
Great idea. Anything with not touched by humans at some distance is great. But one thing I've been noticing since, again, part of my job, vibration.
Yes.
Because vibration in this case may change the alignment, even can lead to a failure, stuff like. So how you control the vibration levels and that stuff?
I think, again, it comes down to a V2 version of this. So right now we have that passive spring suspension system on there to control the vibration as best as we can. We really just wanted to see if we could build this thing in the first one. We have thought about more advanced systems that would use like an active suspension system with compensators on there, or potentially something that leverages gravity a little bit better in its form factor to allow some stability on the pole.
Or in fact, what you can do, you can have a vibration sensor.
Yes.
And include the signal from the vibration
Oh, true.
sensor
Yeah.
to adjust the controls.
True.
Yeah.
Thank you.
Yeah.
Any other questions? One at the back.
Have you considered other applications for this?
Yeah, there's definitely applications in things like we've looked at like oil rigs. There's other pulls out there. Not too much, but we've looked at them and haven't really committed to them yet, though. Yeah.
5 seconds. So one of the applications, I don't know if there's anything with wind turbines but I'm not sure if that's applicable. Probably not.
I have thought about that one. If we just take our device and make it like, I don't know, 10 times larger or something like that, much bigger pull, but you could use a similar system. I think there's some out there for wind turbines actually that have a similar form factor to ours. Yeah.
Great, thank you.
Thank you.
At this point, we'll take a short 15-minute break and then resume with the remaining 4 categories. Thanks everyone who's presented so far. Sponsored by the Lee Company. Lee Company minimizes size and maximize performance with their fluid control technology engineered specifically for aerospace applications. The company's passion for innovation enables it to solve their customers' toughest challenges. And a commitment to cutting-edge manufacturing processes and unmatched quality is the reason why industry leaders have continuously relied on the Lee Company in mission-critical applications for over 75 years. The finalist for this category is Silent Sentry, a software-defined passive sensor for counter-stealth and battlefield survivability. And here to present the idea all the way from Denmark, and sorry if I don't pronounce this correctly, but Robert Merk and Sten Schmidl. I got hopefully that right, but he can correct it. So welcome.
Just grab it. Thank you for having us. It's been a great honor, and it has been a really interesting process. My name is Robert. Sten is over here. I've spent 25 years in the military, and I've served both within the major warfare areas and the combat rescue community. We are dividing this up a bit, so I'll start out and talking about the number one problem or number one issue within those areas is first of all the find task, whether or not you're talking about an enemy or if you're talking about an isolated person that you need to rescue somewhere. Most of all is usually in the contested areas, the find task will be even more difficult. And therefore we are having a now weather independent application for this find task. So without further ado, strap in because Sten is one of the quickest, the most cleverest person I've known. So he will take it away from here.
I'll try to do my best, Robert. So thank you very much. And okay, so what I'm going to tell you is basically how we would like to use well-known technology that we have been researching for the past 2 decades at university level into a completely new context. We already know how that we can map the world using passive radiometers. We apply Planck's radiation law, and we basically build a radio receiver, and then we can characterize our planet. We can do that in many ways. We can measure the Gulf current by measuring the sea surface salinity. We can measure the soil moisture. We can measure wildfires. We can measure droughts. We can measure a whole bunch of things using radiometers. And it has been well known to scientists for the past 50 years, and they have been using this technology from space during the past 45 years. But over the past 2 decades, we have a new threat against our science, and that threat is coming from ourselves as human beings because we demand more and more bandwidth. And what we see here is actually the threats that we are up against. So in the upper right corner, we see how television satellites contaminate the measurements from the sea surface, how the measurements over great land surfaces is contaminated by active radio sources and at many, many different frequencies. So it narrows in our possibility to make science. So what we as a scientists have been doing is that we have developed new technologies to actually detect the interference and remove it. And we already have running processors applied for satellites. We have one satellite in space already applying the technology, and we have many upcoming in the years to come. Over here on the right, we see one of our prototype radiometers that is being flown on various aircraft in Denmark and in many other countries, also already applying the technology, but with one and only purpose: we would like to detect interference. And what we are doing is that we apply modern technology in order to look into the statistics of what we are actually measuring, because to keep things in a simple way, nature is chaotic, it's random, and what humans do is usually not. So we can separate those things, and we can actually see human activity down to 100ths, or in many cases even down to 1,000ths of the level of the natural radiation. So we can also look into the polarization of radio signals. Again, humans are organized, nature is not, and we can do that at the spectral level, at a timing level, so we have many tricks in order to separate what humans are doing and what nature is doing. And the point is, humans do emit radio signals. They have to switch on the smallest electronic device, and we would know that because we need to know that, otherwise as scientists we would produce wrong results. So go build a camp in the Arctic somewhere, think you are hiding yourself, switch on a GPS receiver, and we'll spot you. Because what the scientists would be doing, they would say, oh, that was unfortunate, that data point is contaminated, so we better throw it away. What Robert and I would be saying is, oh, give us that data point and let us know more about it, because then we can maybe even tell you what they switched on. Because there's actually a potential for classification of sources. Scientists also already know how to characterize the different matter they find on exoplanets. How are they doing that? By looking into the emission spectrum. What would we be doing? We would be looking into the emission spectrum of electronic devices. Then we can tell you what they switched on. What kind of vehicle did they switch on? What kind of GPS receiver did they switch on? Is that a Russian one? Is it a Chinese one? Or is it an American one? That would be good to know. And technology is there. We have operational satellites already in space, throwing away valuable data points every day because scientists can't use them. They say, okay, jolly good, give them to us. We have the upcoming ESA mission called SIMMER. It's a multiband. It's a multiband mission that's supposed to be launched within a very few years. They even have further ideas. The Cryosat mission that is being proposed for the Earth Explorer 12 program would be an extremely wideband radiometer receiving background radiation and throwing away a lot of valuable data points. Robert and I know what to do with them. So satellites produce data all the time. We can apply that technology for something useful. Maybe we can point out that, say, within 10 by 10 kilometers, we can find something. Okay, let us build a system that we can put on a drone. Then we can maybe tell you within 10 by 10 meters where the target is. So what would you do about that, Robert?
Thank you very much. I hope you just got at least a bit of it. We are talking about several applications for this, and I'm sorry to say for the judges that, for example, the B-2 stealth bomber would also radiate something about that. So we have a anti-stealth capability in this. And for soldier safety, we will also have the opportunity to look into a passive sensor that might be working in conjunction with radar, which is an active sensor. as a rescue in rescue situations, we will have, for example, on Iceland, in mountain ranges, in the vast ranges in the U.S. or in the icy currents of the Bering Strait, you would be able to pinpoint people much faster than you could right now, because you can see through cloud and the bad weather. You can do that from a distance. That will also mean that you would eliminate the risk for the rescue people. You would eliminate the risk for the person in trouble, because they would be rescued a lot faster. So less time on station for the rescue community, and more time or a quicker find would increase the survivability of all parties. And if you're looking into, as you said, the profiles of signatures, when you start collecting a lot of this data, then we will be able to go into to cataloging and setting up profiles for each and every single transmission. So, and the transmission data would be different, or the transmission profile would be different from, for example, a T-72 or T-80 tank. So you'd even be able to look into how you can categorize those from a distance. I don't want to get into antenna theory, but and again, Steen can do a lot more about that. We are currently in a position where the only thing we need is more capability and more manpower to work on this project. Right now, it's us two, and we are currently looking into hiring a PhD on this event also. So the more effort we put into it, the faster it goes. But since it's a small company with only limited resources, we of course are working as fast as we can to get into this. Pending your questions, that was the presentation. Thank you.
Judges, questions? We'll start from the back.
You mentioned an awful lot of uses for this in the geospatial regime and size distance. Are there any that can be used on smaller areas, such as I'm thinking of even an oil, gas, petrochemical plant that would help to monitor some of the local activity on that size scale?
Yeah, the issue is, again, looking into antenna theory, that you can put any antenna at any size on whatever carrier you have. So you would also be able to, for example, put it on ships, which can carry a bigger antenna, and then you would be able to spot aircraft and other stuff flying around. But the more stationary a platform you have, the bigger the antenna without any risk to it. Right now, as Steen said, since it's measuring currents, the antenna on the satellites have very high resolution. So we're looking into very big pixels. But if we can do that with putting, for example, on a drone, we could even hover in a very, very low distance, and we could also even use it for mine clearing and something like that.
Next question.
So the way I understand it is it can make use of existing sensors, like you had all the satellite examples. That hinges on you getting access to the data. I mean, obviously that's a question. And the combination is like a synthetic aperture or like a very large array or interferometric. I'm not quite sure how you get the resolution, how you get the ground or the sea surface without interference of the surface.
Yeah, I think we need to see the solution twofold. First, getting access to the data. The satellites that applies this kind of data nowadays is mainly civil available data. So that means you can go to the homepage of ESA or NASA and download the data. You will just see that warning flag, don't use this data point for any scientific use because it's contaminated. So that's basically where we will start. But where I see the real potential and what I see the idea that our PhD students should investigate is actually to get a system up running similar to the prototype that I showed a photograph of, and get that up running either in a stationary field setup or actually building a version that is capable to fit on a drone. And there's nothing in technology that wouldn't make it fit onto a drone. So I mean, you can build it into a matchbox and you can still make it work. And that's where I see the scalability, that you use the satellite to point out, say, you have some activity into a 10 by 10 kilometer space in Arctic, then you launch your drone into that area and investigate in details where is actually that activity. But that's what we need that's what we need the PhD student for. But from a technological point of view, there would be no obstacles because we use the well-known technology already existing.
Is there a possibility to, so, you know, for military purposes, could they create a simulated signature?
Just to make sure I understand your question correctly, so you think if they would be able to create a signature that would spoof our system in a way so that we would think they have some activity there? And
like we could have a B-2 bomber, but it could put out a signature of a 747 or an MD-11, right? If they deliberately tried to create that signature.
In a sense, they could, but they still need to hide what they already emit. And if they try to, say, create a stronger signature to, like, overrule the natural signal coming from the bomber itself, so then they would, in a sense, try to spoof us, but we will see that the signal is unnaturally large, and then we will see that something suspicious is going on there.
Okay. And one other question related to that. So if you know what your signature is there a possibility of generating an inverse of that to try and cancel it out?
Well, theoretically, you can always cancel a signal out. The problem seen from you as the user of any electronic device would be that what you cause of a noise signal would be something that you are typically not in control of, because if you would be in control of, then you wouldn't emit it anyway. So it might be theoretically possibly to think of mathematically cancelling out the signal, but since you don't know what you are emitting until you already did so, then it would be difficult for you to counteract it.
I have a question. Is this on? Yeah. All right. Thank you. Yeah, with regards to both the stealth and counter stealth comments you had up there, I mean, your radiometer produces some signal, so which is then detectable. So how do you get around that in a say a stealth aircraft?
Again, just to make sure I understand your question correctly, so our radiometer is a passive receiver, so we are in a sense only emitting what we are not in control of, and we should not be emitting anything, otherwise we would reveal ourselves, but we are not emitting any signal like a radar does. So that's a major difference between a radiometer and a radar, that we are basically only receiving. So if we emit anything, it's only because we have not shielded ourselves carefully enough, exactly as the emitters that we are going to try to detect. But we are a passive sensor, so that was just to make sure I understood the question correctly.
Okay. Yeah, you did. I didn't quite understand that. It was purely passive sensor.
Yeah, it's a purely passive sensor, that's true.
Okay.
Great. Thank you.
Thank you.
Did I give it to you?
You didn't. Well, next up is the finalist for the category Energy, Power and Propulsion, the ultra-efficient hydrogen combustion for clean distributed power and propulsion. And I would like to invite on stage Don Krasinski to present the idea.
Good afternoon. I'm a bit of a roamer, so I'm going to roam with the mic here a little bit. My name is John Krasminski. I am the CTO and founder of Alpha Auto Technologies. We are focused on the next generation of reaction-based energy systems that produce take chemical energy in fuels and convert that to mechanical and electrical energy. There we go. To put this in perspective, the energy demand is growing exponentially. What I like to say is every other innovation, in fact, probably every finalist and sponsor in this room, relies on power and energy. AI, data centers, electrified industries, electrified transportation, all rely on energy production. Again, this is a huge problem that's growing. To kind of bound the problem, we are adding Japan's entire power consumption to our grid demand every year. There's many impacts in life where you remember where you were at. I might be dating myself, but I remember where I was when the 2003 blackout occurred that took out the whole northeastern coast. That left 55 million people without power. The grid today is no more resilient. We've gotten lucky. In fact, it's almost worse because of these other technologies that are demanding power from the grid. To put this in a graphical illustration as well, in a use case, the light blue line represents the power demand in a municipality. The green shaded area is the power that is produced by the on-site renewables. Since that 2003 blackout, we have done an excellent job of adding renewables to our grid. However, this introduces another problem. How do we fill the gaps? This is where our technology comes in. We fill those gaps, allowing the use of renewables and then filling those and firming the grid with our energy production. Now, I'll get into this a little bit more later when I get into the science of our technology, but we can do this with any local fuel. So, for example, if you're in Brazil, you might be using an ethanol-based fuel. In the United States, we may be using a white hydrogen. With a reaction-based system, we can generally use any fuel cleaner and better than what's being used today. We're born out of Detroit. I moved to Detroit 20 plus years ago to specifically be in this area. This is a real technology. You can see it running here on the screen. And I put 20 years plus in the automotive sector to develop my knowledge in this sector. And after having kids, I kind of said, okay, what is my knowledge base? How can I change the way the world that we live in today? And I know engine development, I know power system development, and this is what really founded the mission at Alpha Auto Technologies. Now getting into the science, and I'm sure my kids, going back to them, really enjoy our dinner time conversations. I bore them with this all the time. What we're doing differently is we have I'm going to use the terms reaction and combustion. In engine development world, we somewhat use these interchangeably, but semantics do matter. We have a core engine architecture that contains the reaction chamber and power cell. And then we have support systems around that reaction chamber that allow us to control exactly what reaction is occurring inside that power cell. On top of all this is the electronics and control system that make this all possible. Here's a animation of the power cell and the reaction chamber working, though this is only a small portion of the system. I'm not showing you here the preconditioning systems and the scavenging systems outside of this chamber, but the core reaction chamber itself. Now, I mentioned earlier the usages of traditional fuels as well as clean fuels like hydrogen. Well, using traditional fuels, the reaction-based system, we can do much cleaner. So by nature, we can eliminate CO emissions, NOx emissions. Mansoor did a great job earlier educating you all on NOx emissions. We'll get into that later. But this improves thermodynamic efficiency and eventually the mechanical efficiency that drives the generation system. Thermodynamic efficiency is just a fancy way of saying we can use less fuel to produce the same amount of power. Now, diving into the details of the tech and actually how it works. The graphs here on the right-hand side, the orange curve shows what we call near constant volume energy release. What this basically means is when we get the reaction occurs in the reaction chamber, we get a high spike in internal cylinder pressure. And what that allows us to do is we get a average pressure that is similar to that to a spark-assisted or compression ignition system, but we use less fuel to achieve that overall average pressure. That pressure turns into mechanical work, and mechanical work turns into the electricity generated by the system. Now, what's really important is the curve underneath it. This is the temperature release profile of what's actually happening inside that reaction chamber. Now, Mansoor pointed out earlier, it was actually nice that we went after his presentation, that heat is what causes NOx emissions. If you don't produce the heat, you don't produce the NOx emissions. So having a reaction-based system versus a traditional flame front combustion-based system drastically reduces NOx emissions with all fuels. This is a visual representation of what's actually happening inside the reaction chamber. The left-hand side is traditional combustion. The right-hand side is that constant volume energy release that I mentioned. Now, specifically with hydrogen, hydrogen is one of the most difficult fuels to combust. But when you use it in a reaction-based system, the byproducts such as NOx are produced because hydrogen burns at such a high temperature. The other problem with hydrogen is its flame speed. Flame speed and NOx are not an issue when you do it in a reaction-based system. So this essentially turns hydrogen into a 100% clean fuel with the only byproduct out the exhaust system being water. I want to impress on you, though, that this doesn't mean we can only use hydrogen. We can use any available fuel and combust it in this manner. This is real. We are on our second generation demonstration platform. We've ran this on multiple fuels, including hydrogen, and already have test data on that. And our current focus is developing the control algorithms and the electronic brain, the intelligence behind the system to make this function in real world applications. How are we deploying this? We're taking our core reaction-based system and turning that into a micro modular power plant. What I want to also impress on you is this isn't just a power generator that you put next to your home. This is megawatt scale to firm the grid so that you can produce power where you need it. One of the biggest problems that we have is getting power across the country from where it's produced to where you need it. By making this modular, this can be put where the power is needed and we don't need those transmission systems. We have huge opportunity to address several key markets: data centers, critical infrastructure, defense, microgrids. These each offer huge market potential for us to penetrate, but also allow us to address specific pain points in each of these industries: power consumption, uptime requirements, and capacity requirements. As I mentioned, we can use traditional and clean fuels. By just replacing a small amount of firming fossil fuel power generation systems, we can reduce millions of tons of CO2. We are not producing the NOx emissions. We're not producing the particulate emissions that are typical of other combustion systems. And what we're doing is, from a national security standpoint, We're firming the grid where we're producing, again, power where we need it. Our goal is to take this and basically scale this and adapt this to, the next step is to adapt this to actually hooking our systems up to the grid and supporting our goal of basically clean power anywhere, anytime. What I also like to say is that we're not only powering innovation in the sense of all other technologies require power to function, but we're also innovating power. Thank you again for your time, and I'll take any questions.
Any questions?
Good stuff. In fact, this is a question I've been asking for everybody who is using hydrogen. I'm reminding them of January 27th, 1967, when Apollo 1 was burnt on the launching pad, killing 3 astronauts. It turned out because I was involved in using hydrogen for hypersonic engines. And it came out that what type of hydrogen isotope we use. Is it parahydrogen or orthohydrogen? And the difference between them, one is stable and expensive to make, and the other one is cheap and unstable. And unfortunately, NASA used the one which is unstable and cheap, killing 3 souls here. So did you take that into consideration of the type of hydrogen we're going to use?
Yes. So one of the biggest problems, not only talking about the stability of hydrogen, but is the purity of hydrogen. And when you look at competing technologies like fuel cells, the purity matters a lot because of the catalyst type of reaction that's happening. We can use basically any type of hydrogen because once we understand what's happening inside the reaction system, we're adjusting our outside parameters to get the reaction that we want. So it doesn't matter if the hydrogen is unstable, we just adjust our system for that.
Any other questions? Anybody at the back?
So if I understand it correctly, one major part is you have that external valve on the input and output that makes the loss that you have in a normal 2-stroke engine of the mixing better. And that's a big part of the innovation. Is that correct?
Yeah, what I would say it's how the gas exchange is happening inside that reaction chamber is the innovation. So it's not just the fact that 2-stroke has a ton of benefits to it. I hate to use that term because there's so many negative connotations with 2-stroke engine technology, but 2-stroke has a large amount of benefits just because of the amount of turbulence you create inside that reaction chamber prior to ignition. So that keeps the mixture homogeneous before ignition occurs. So the valve is part of that system on how that gas exchange occurs.
You talked about being able to burn different types of fuel. So when you change, if you had a unit at a site and one type of fuel is available for a period of time and then later on a different type of fuel is available or more economic, what's involved in making that switch in the system?
That's a great question and exactly why we developed the system for that reason. So one of the problems you may not know this, but even fuel supply that you use today is different from gas station countrywide where you're getting it. There's a ton of difference in fuel supply. So our goal is to develop it that if there's a cheaper, cleaner fuel available to you, there's no changes in the system. Right now in our prototype phase, we are actually literally flipping a switch for the different type of fuel. But our goal is we're going to actually sense what's happening inside that reaction chamber with our control algorithms. And it doesn't matter if the fuel is changing daily or really cycle by cycle is what we're doing. So let's say we have a slow drift in our fuel supply or a sudden change, a step change. Our reaction system will adjust to it.
One final question.
Regarding storage, how do you minimize the leakages of hydrogen?
Do you mean leakages where?
Yeah.
Just in the system overall? So one of the biggest problems when you use any hydrogen system, as you're mentioning, is the permeation of hydrogen out of the system. In a traditional combustion system, it usually happens when you're injecting it into the intake stream, and then you have time to permeate. One of the advantages of our system is we're immediately injecting the hydrogen and combusting it. So there's about a third less time because of the two-stroke architecture that we are able to control when the hydrogen is injected and initially combusted. All right.
Thank you. All right, thanks, John. And looks like I broke this now. All right, here we go. Our next category is electronics, and it's sponsored by Summit Interconnect, a privately held PCB manufacturer with field application engineers across North America. With top-of-the-line equipment and redundant facilities, Summit is the clear choice when selecting a manufacturer for mission-critical PCB designs. The company's 8 high-tech facilities offer customers a complete portfolio of PCB services from high-max, low-volume programs, including HDI rigid, flex, assembly, and quick-turn prototypes. And the finalist for this category is 100x audio digital to analog performance improvement. And to present, we have John LaCroix. So welcome, John.
Hello. SAE Media, thank you. This is great. Judges. My favorite Buckminster Fuller quote. So I'm John. I'm the founder of Millennia Music and Media Systems. We make the most used mic preamp for film scoring, classical music, and acoustic jazz. We have over 50,000 channels of this mic preamp in use worldwide. We were inducted into the NAMM Technology Hall of Fame in 2019. If you've watched a movie today or listened to music, chances are you've heard a Millennia recording. So in 2013, I had a dream, literally woke up with a new audio architecture. It's kind of a long story, but I'd been thinking a long time about architectures, and it just sort of was there. And I went into my office that morning, and I erased my whiteboard, and I put this idea as much as I could on the whiteboard, and I've been working on this idea for 12 years. And this is the result. It's the immersive D1 digital to analog converter. I brought a sample there. It's sitting on the bar. If anybody would like to see it, there's some literature over there too. This D to A converter improves today's very best D to A conversion specification by 100x at least. That's today's very best. It improves it by 100x in dynamic range, linearity, noise reduction, and THD plus N at atmospheric levels. And these are the critical aspects of audio. So how do we improve audio by 100x? The best analogy I've found is called high dynamic range photography. Some of you may be familiar with it. It's actually in some cell phones now. So in HDR photography, we don't just take one photo, we take multiple images of a single object. And each image is taken at a different aperture, say f/16, f/8, f/2.8, and so forth. Some take many more photos. Then we use a digital signal processor to intelligently combine the very best aspects of each photo into a high dynamic range photo. This turns out to be almost a perfect analogy to what we're doing with audio. And we call it HDR, High Dynamic Range Audio, HDRA. We've received so far 3 domestic and other international patents, and we have more patents in the works. We We start with a digital signal, conventional digital signal, and then we break it into two pathways, a low path and a high path. The low path is very low-level audio, very quiet, which is just like low-light photography. The high path is very loud audio, which is just like a very bright photo. And in the same way, we use digital signal processing to extract the very best aspects of each one, which you couldn't do on a single path. And then we use DSP to sum them at the output, giving us 168 dB or 28 bits of dynamic range. This is HDRA multipath processing. And you can see, compared to today's very best, single path legacy audio, we're 40 dB greater in all the critical parameters, which is 100x, 40 dB, 100x. So there have been 3 dynamic paradigm shifts in the 140-year history of audio. Of course, the original paradigm was Thomas Edison in the 1880s with the phonograph. It gave us about 20 dB of dynamic range. The first paradigm shift happened because of the vacuum tube in the 1920s, electric audio. This gave us about 50 dB of dynamic range. The second paradigm shift was magnetic tape in the 1950s, which gave us about 75 dB of dynamic range, which is about a 25 dB improvement over the first paradigm shift. And the third paradigm shift was digital audio, which gave us about 95 dB of dynamic range, and today that's grown to about 130 dB. So you can put that on a graph. From 1880 to today, the average improvement of linearity dynamic range has been about 0.8 dB per year on a long moving average. But 70% of this growth is attributed to just 3 paradigm shifts, step functions, which we've just talked about. The first, electric audio. The second, magnetic tape. And the third, digital audio. HDRA, high dynamic range audio, is actually the 4th paradigm shift. It's the greatest improvement in audio dynamic range in the history of audio. Nothing has given that level of step function as what we've done. So keep in mind, this isn't about loudness. We're not making everything louder. We're making everything quieter. We're pushing our noise limits down 40 dB. So what's next? It's my goal to apply HDRA processing to every element in the signal path, and I know how to do this. You start with microphones using a dual path microphone system, a dual path ADC, and so forth. Here's a multipath power amplifier. This is one of our patents. Here's the entire roadmap. You start with microphones into preamps, ADCs into a 32-bit perfect DAW, D to A power amplifier, and summing, giving you 170 dB dynamic range from microphone to power amplifier at the very end. A couple years ago, I got a call from NASA, from Anthony Yu at Goddard, and he said, I hear you're the preamp guy. I said, okay, that's great. We have a mission we're working on. We need a preamp that's 10 dB better performance than what you have in your audio products, which today are the highest dynamic range available in audio. Can you do it? And I said, okay, I'll try. And it took a year and a half. Applying HDRA technology, we actually exceeded, for this gravity wave mission that's going up in 2034, we exceeded NASA's spec. We achieved minus 145 dBu EIN. And now I'm applying this to audio. So it's a pretty big deal. Any application that uses transducers or conversion, A to D or D to A conversion, can benefit dramatically from HDRA processing, including neonatal imaging, medical, neural sensors, when you see all the sensors that can greatly improve the sensitivity, bioacoustic microscopy, non-destructive testing, acoustic emission monitoring, sonar and hydrophone, gravity wave detection, gas spectroscopy, seismic testing. These can be improved by at least an order of magnitude, if not more, using this technology. And of course, audio equipment and audio test equipment, which we're developing as well. That's it. That's what I've got. Thank you.
Questions, judges? Anyone at the back? We have one at the back.
Can you give some examples of where you've used this, actually applied it in what could be considered a commercial type of operation?
Yeah. Well, I've been working on the first commercial product for 12 years. And there it is right there. It's sitting on the bar. We've been shipping it now in production for a couple months. So it's real. It's actually happening.
And what's the application for that it's going into?
Right now, this is pure audio. So our main focus is professional audio, but also for home audio and elsewhere. But you can see many other things coming.
And would I, with my aging hearing, notice the difference?
You would. Oh, God. Yeah. I don't have it hooked up, but I could.
Okay. Yeah, you mentioned that you had 50 beta testers that you were getting feedback from.
Yes.
And that you were planning to start selling this, and it sounds like you actually have. Can you tell me what your revenues are to date, and what your profit margins are that you are looking at the moment, and how are you going to reduce the cost of producing this?
Yeah, it's interesting. Our main, we're getting into the weeds now, but our main dealer is called Sweetwater. And they're the biggest retailer in the country of this kind of product. And they're going to have this live on their site in about 2 weeks. I was just there last week and get over 100 salespeople, gave the whole thing. We were in the studio, they got to hear it, they flipped out. But we're selling probably 2 or 3 a week right now.
So how many has that resulted to date, and when did you start selling?
The beta test period was when we started we went to mastering engineers. Mastering is the process of after you mix your song and it's just about ready to be released, it goes to a mastering engineer who then polishes it and makes sure it's perfect for release. This is perfect for mastering engineers. They need to hear precisely what's going on. We went to about 50 professional mastering engineers. Over 30 have purchased their unit to date. Yeah, so 60% acceptance rate. And if you go to the website, they all have comments, and they're just like over the top. They just say, this isn't just a little improvement, it's a big, big improvement in audio.
Okay, so one follow-up question here. I noticed the unit you have over there is fairly big for what I'm going to ask you now, but can this be integrated into hearing aids?
Yeah, that's a great question. It's my ultimate goal, besides getting HDRA into the entire signal path from microphone to power amp, is to get it miniaturized into integrated circuits. Right now, that box has over 1,500 components, because this is not easy. It's really complex. We've given Mouser a lot of money. Which, by the way, I've been working with Mouser since it was a little 6-page catalog that got mailed out. Yeah, that long. God, I'm old. And this can be reduced. Every function in that box can be reduced to an IC. You can put it on an IC. It's just a matter of time. And I think eventually multipath audio architecture will be the next paradigm of all audio. I think it can't. There's no way we can do it in single path right now. We're stuck. You have a noise floor and you have a dynamic limit. And if you try to move one down, the other one comes down. If you try to move one up, this comes up. When you break an audio signal into two paths, now you can reduce your noise dramatically. Nothing changes here. And you can raise your headroom. Nothing changes here. This is the way forward for anything that's using transducers, A to Ds, D to As.
We have a question in the front.
Yeah, thanks. I was wondering, you've got the sound engineer stuff down, but what do you think is the next application? You listed many. So what do you think is number 2 on the list?
Of that long list?
Yeah.
We've been talking with some seismic companies, and they need this. Also, audio, yes, audio listening, but also audio test equipment. You can't test this with today's equipment. The noise level is so low, it's about 25 dB below our best audio test equipment. You plug it in, nothing changes. You can't measure it. So we're developing test equipment that you can actually test multipath performance.
Thank you.
Yeah.
All right, great questions. Thank you, John. Okay, last but not the least, we have the manufacturing and materials category sponsored by Hunlei. Hunlei Adhesive Americas is one source for both industrial assembly adhesives and UV LED curing systems. As part of the global Hunlei Adhesives business unit, they supply UV adhesives and coatings, epoxies, conductive adhesives to optimize the curing of UV adhesives and coatings. Hunlei also provides high-power, broad-spectrum UV and monochromatic LED curing systems made by Hunlei that are suitable for manual workstations and high-volume automated processes. Presenting the finalists for this category, React, automated capsule recycling technology for a circular coffee industry. On behalf of the team is Felix Melpartrida from Spain. Welcome, Felix.
Hello. Okay. So it's a real pleasure to be here. It's a very impressive set of technologies. I'm an engineer and then I love looking at all these innovations. But I come for something totally different, something as mundane as having a cup of coffee. And actually most of us don't realize how damaging it is for the environment, especially when you're using one of these capsule coffees made of aluminium, and it's highly contaminant for our environment. React is the name of the product. I brought a prototype here, and the best is probably that we play a very short video of 1 minute so that it actually explains what is the environmental challenge and how we are resolving it. $7 billion capsules a year, and less than 10% of those are being recycled. So this is our coffee machine. I will explain later what it does. And essentially, when you prepare a coffee, it automatically separates the organic coffee remains from the aluminium capsule.
For on-demand news 24 hours a day, subscribe to Bloomberg News Now wherever you get.
And then you can follow into 2 different recycle paths.
Thanks so much for that update, Charlie Pellet. It's the stuff of fantasies.
So essentially, as you could see in the video, the problem of the coffee capsules is a huge problem, and it's a growing problem worldwide. 60 billion coffee capsules are consumed worldwide, and then less than 10% are recycled because it's very costly, the separation of the organic substance from the aluminium. And unfortunately, most of them end up in a dump. Most of you are engineers, so you know the melting point of aluminium is about 600 centigrades or more than 1,000 Fahrenheit, so it doesn't melt when you go into dump and they burn it. And then this is creating a growing environmental issue pretty much in all the countries in the world due to the growth and popularity of coffee capsules. Then our team, what has developed is a patented technology. It's patented across US, Europe, China, and a few other large countries, where actually you make a coffee, as in a regular coffee machine, and actually at the point of making the coffee, we have developed the solution and the technology to separate the remains of the coffee from the aluminum capsule. And this is how it looks like. So it becomes totally kind of clean of capsule, and then you can throw this into the recycle bin, and then you can use the rest of the coffee as organic waste for any kind of other use. Then in reality, we have developed 4 different products. We've been working on this for 5 years now. The original idea, React Single, was actually that a device that you buy for your home, single personal use, and actually you put the used capsules, and then it splits the two. The coffee remains from the aluminium. Of course, this has limited use. Then the next solution is to do this at a scale for the hospitality sector. So you could actually do like 20, 40 capsules in places like hotels, restaurants, and so on. But then the real innovation comes now with the React coffee machine, which is actually the prototype that we brought here. So here actually it's a regular coffee machine that actually has our technology integrated and automatically separates the aluminum capsule from the coffee remains. And then we are looking essentially for partnerships for doing this manufacturing at scale, trying to get orders from coffee machine makers and manufacturers, from retailers that would like to contribute to the environment by making this kind of a white label product. Because actually we don't realize that having an innocent cup of coffee, we actually contaminate so much the environment. In terms of the market size, just looking at the US figures alone, the market size of coffee capsules in the US is already projected to be 21.8 billion, growing at something like 4.8% the next 7 years. From this, we estimate the serviceable market is around $3 billion annually, just focusing on hospitality sector, food service, and offices, where actually there is a growing use of coffee capsules. And we believe that actually the obtainable market, very reasonable, would be something around $100 to $150 million annually, just focusing on the machine OEMs, coffee machine OEMs, and hospitality chains. On top of this, what we see is actually that in many of the commercial uses, like offices, hospitality, restaurants, and so on, the convenience of not having to prepare the coffee for someone makes that actually this is growing at 10% annually in the last couple of years. So actually it's a growing and growing and growing problem. Then lastly, in the US, the number of households that have adopted a coffee capsule machine is around 41%, but actually in other countries, like for instance in Spain, this is 72%. Okay. So there is a huge problem coming underway. And then the environmental impact, because of course we can see that it's very good, but how big it is, right? The reality is that the CO2 saved from all of this process is actually for 1 ton of aluminum, we save 9 tons of CO2. Okay, because it's a highly inefficient process. One of the elements is the transportation. Today, actually, you would have to take the coffee capsules to have people wasting them into the right bin, and then they are transported, generating CO2 to a recycling center where actually only in 10% of the cases they are recycled. Now with this system, actually it is recycled at the point of use. So actually we eliminate a big portion of the CO2 emissions by eliminating the transport. Awards and recognitions, as I mentioned, we started 5 years ago. We started with the first single machine with a patented technology. Then we evolved into the React Hospitality prototype that was validated, was our first investment round. Then we got several loans from the innovation agency in Spain. And now we also got a grant from the European Union Manufacturing, let's say, Technology Innovation Organization. And now we are actually in PCT patent concession across, I think it's something like 32 countries. And then we just secured our first order from a coffee maker that actually wants to have their own coffee machines. They place an order of 1,500, and we are actually now trying to raise 500,000 euros, something like 580,000 US dollars. In terms of competition, it's quite interesting because there are other people trying to do this, but essentially we have 5 years advantage versus 1 or 2 years. So the other two, they provide the clean capsule, but actually it's not integrated into the coffee machine, which is actually the real innovation. The other thing is about being economic, being compact, and also to target a kind of a price tag that actually can drive mass adoption and not only kind of early adopters. Then, of course, there is alternative of compostable capsules, which actually they are becoming more popular, but of course they are 30 to 40% more expensive, which actually becomes very difficult to adopt from a consumer point of view. In terms of business model, we also have 3 different business models. The first one is kind of a B2C model, where we are actually selling the React S direct to consumer, mainly, and also we will also are targeting to do this mainly via online channels. The second one is a B2B model, mainly for hospitality sector, which is more of a subscription service, where we provide the machine, and then on a regular basis we just recover all the capsules from aluminum that have been separated from our machine. And the last model, which is the one that we are very much interested, is kind of a B2B2C model, where actually we sell the new coffee machine at a price point of 150 euros, which is around $165 per unit. And actually we think there is a huge opportunity here. The last of the business models actually is a license model for other coffee machine manufacturers that actually they could also use our patented technology to incorporate into their coffee machines. Our value proposition, you can immediately understand that it's around sustainability, convenience, because this is a lot easier to use, compliance with all the new regulations around reducing CO2 emissions, and of course affordability, because we have managed to do the design in a way that actually can be affordable for every household. And as I mentioned, we are raising now $580,000. Our focus, as you can see, is actually the mold for doing industrial manufacturing is actually the most expensive part. And the more orders that we have, now we have an order of 1,500 units. If we are able to get to 10,000 units ordered by someone, it would be ideal, because then we can really leverage the investment into the molds, the industrial molds, and then the rest is all marketing, production, overheads, and the typical kind of operations that any company like this would require. That's it.
And questions from the judges? If you read this. Start. Yeah.
Thank you. Very nice. So you might mentioned the recycling at the point of use. Maybe I missed something in your second to last slide. So you still have to get the aluminum to the place where it does recycle. Do you have a proposition for that?
Yeah, well, essentially it's like if you have this coffee machine at your home, then you make your coffee, and then you take this and you throw it into the recycling bin, right. And then it follows the path of the recycling for recycling materials, and the other one is all the organic.
Sure.
And that's it. So essentially you avoid all the other complexities.
All right. And then aluminum is not a rare element. So the cost of production of like a kilogram of aluminum, how does that compare to recycling it? It's mostly like regulations based or customer preference based for sustainability. Is that correct?
I think so. I'm not an expert on that, but yes, I think so.
Yeah. The other challenge that you run into with that recycle path is unless that recycle path is educated, and I mean the recyclers, I'm not talking about the consumers, unless they know that that's clean enough to recycle, they will just throw it out themselves, and it creates a problem for them, not an assistance. So what are you doing? What are you doing to signify that these cups are clean cups as opposed to the ones coming out of other machines that are not?
Well, yeah. I mean, by visual inspection, you can already see that there are no remains here. Okay, so it's kind of almost common sense. But I agree totally with you. The challenge, when all these coffee capsules were invented more than 30 years ago now by Nespresso or Nestlé, they already knew that this was going to be an environmental problem. They designed massive machines that cost several millions to be put at recycling centers for the recyclers. The problem is that these machines are very costly, and most of them, they don't have them. So now, when the capsules arrive to the recycling center, they just go to the dump, because it's very costly to separate the organic from the inorganic. Now, with this, of course, we will have to kind of re-educate the recyclers that now some of the capsules you can actually recycle properly. But I think that is a lot easier than the current situation where we are.
Yes. So on most recyclable packaging, at least in the United States, there is a triangle with a number. And so there's a certification process. So have you gone through any certification process for that aluminum to achieve that?
No, because we are focusing on the coffee machine. So in theory, it is recyclable, the coffee capsule.
Right.
The problem is that in practical terms, is not.
Oh, so that, unless it's practical, you need to get to that point. Right?
Correct. Exactly.
Yeah. So there's a certification there's a certification step that you have to go through before that can realize its benefit.
Well, I think we need to drive adoption. Well, first of all, I think we need to drive awareness that the current coffee capsules create a massive environmental issue.
I think most of us know that.
Most people already know that. Okay?
It's that there is a solution to that problem.
There is a solution to the problem. That's what we need to do a marketing campaign to explain to people, like, actually there is an alternative coffee machine that if you buy, you could actually do it. Or there are certain coffee machines that could have kind of a double recycling sign, saying like it's not only the coffee machine, but actually the actual use of this machine reduces the environmental and
Right.
CO2 impact. But we haven't
in
gone through
parallel,
that.
you are going to have.
We haven't done that.
You're going to need both
Correct.
because if the recycler can see that stamp on that package, then he knows he can put it into his aluminum recycle.
Correct.
Stream.
Correct. Correct.
Did you?
Two.
Sure. Just a follow up. Have you considered taking the aluminum foils back in the subscription model, like just as a follow up, because recycling is challenging? So, would that give the customer a discount for being a good citizen?
Correct. Correct. Absolutely. So we are a small startup, so we need to start getting the coffee machine made, manufactured. Actually, I believe that very soon some people will start doing that kind of, let's say, subscription service to recover the aluminium. We already got approached by 2 companies in the kind of metals and recycling industry who said like, oh, we really want to get all the hold of all the aluminium from there, right? But we said, yeah, we need to drive adoption to be able to produce tons of aluminium for you. But yes, there is a business to be developed once we get mass adoption.
We had a final question.
I was just going to follow up on the recycling bit. So you would behoove yourself to talk to recyclers. A lot of small objects such as this, it doesn't matter unless they're a pure bar. They won't handle anything less than a fist or less than a deck of cards. So something this small will just jam their system. Even the more modern systems will just jam. I don't know what metal, I know it's aluminum. I don't know what series this is, if it's a 5000, 3000 series. There is some drawing. I don't think there's ironing to this component. But you need to make sure that they are willing to take that metal as well. But for the most part, unless it's somehow packaged that their machines will not jam, they will discard the entire lot coming in.
Yeah, it's a great point. It's a great point. So we have talked to actually, I mean, me myself, because I know some people in the recycling industry, but also the team has had several meetings with recyclers. And yet, as you mentioned, they say, okay, this is problematic for us, but it's less problematic if it already comes totally clean from organic. Because for them, the problem is the organic component. And then the next challenge is the size and how we can, let's say, educate them, right?
10 seconds. So the key is that you made it clean. And Susan's point, you could probably thought of this too. You could crush them and combine them into bigger blocks, and that might solve that problem.
Correct. Great idea.
Well, thank you for answering all the questions, and thanks you for the great questions there. And so that was our last presentation, and I want to thank everybody for their excellent presentations here, and to the judges for your questions and taking the time to evaluate. Big round of applause for everybody. And at this point, we are going to take a break, and we'll take the blue folders from you guys, all the judges, to tabulate the scores, and we'll be back with the announcement of the winner in some time. So stretch those legs, grab a coffee. And before we announce the winners, I think let's have another round of applause for all the finalists who did an excellent job presenting today. I'm sure it's been a very hard decision for the judges to even, score all the technologies. So not an easy task, not something I would be able to do. So now I'm going to start by announcing the category winners, because like I said in the beginning, right, if you're not the grand prize winner, you win your category. Until now, you were a finalist, but now you're a winner of your category. So the category winner for aerospace and defense is Silent Sentry. Okay. The winner for automotive and transportation is making diesel engines emission-free. The category winner for energy, power, and propulsion is the ultra-efficient hydrogen technology. The robotics and automation winner is the woodpecker. The winner for medical is blood viscosity. The winner for manufacturing and materials is REACT, the automated capsule recycling technology. And the grand prize winner, now you know, is the electronics category, 100x audio digital to analog performance improvement. John Grove, congratulations. And please come on over to receive a giant check from Joe. And please join me in congratulating our grand prize winner. And would you like to say a few words?
Oh, I just, thank you so much. Wow, this has been 12 years of my life. That thing right there, just blood, sweat, and tears doing engineering that no one's ever done every week. And this is just the greatest thing. Thank you to SAE. Thank you, judges. Appreciate it so much.
Well, to every participant here, thank you for sharing your incredible ideas and creativity with us. And a big thank you to our esteemed judges. Can't thank you enough. It's not an easy thing to, score these technologies that all look so good and have such an impactful, designs here that everybody brought their ideas here. And I also want to say thank you to our awesome SA Media Group staff, Marketing Director Caitlin, Summer, Chris in the back with the timer, and Andrew Corselli, our digital content editor, and Joe right here. So Brian and Desiree also. Who did I miss? Who did I miss? Sorry. If I missed anybody, thank you. And before we wrap up, please, all the winners, category winners and the grand prize winner, please come up. We want to take a group photo for the entire, all the presenters and the sponsors. Yes. Thanks, Joe, for a reminder. So please come on up here, all the sponsors in attendance and the winners for a group photo. Heidi, Bernd, Oscar. Who did I miss? From Zeus, John.